we now discuss the solution of a problem from the section Differential Calculus. The problem is on the continuity and differentiability of a given function in a given domain. This question has appeared in the joint entrance examination main held on 26th June 2022 in the second shift. The given question is, let f of x is equal to minimum of 1, 1 plus x sin x in the interval, closed and bounded interval 0 to 2 pi. If m is the number of points where f is not differentiable and n is the number of points where f is not continuous, then the ordered pair m comma n is equal to, we are given 4 options. Option A 2 comma 0, ordered pair 2 comma 0. Option B 1 comma 0. Option C 1 comma 1. Option D 2 comma 1. We are given this function defined in the interval, closed and bounded interval 0 to 2 pi. And if m and n represent the number of points where f is not differentiable and f is not continuous respectively, then we have to find the ordered pair m comma n. We have this given function f of x is equal to minimum of the first function 1, the second function 1 plus x sin x, where 0 less than or equal to x less than or equal to 2 pi. And m denotes the number of points where f is not differentiable. N is the number of points where f is not continuous, required to find the ordered pair m comma n. First, note that 1 plus x sin x is greater than 1 for all x belongs to the open interval 0 to pi. Why? Because x sin x is greater than 0, yes, for all x belongs to 0 to pi. So x sin x is greater than 0, yes, sin x is positive in this interval 0 to pi, and x is anyway 0 to pi. If that's also positive, the product is positive. And therefore, f of x is equal to minimum of this greater than 1 and 1 plus x sin x. The minimum is 1. For 0 less than or equal to x less than or equal to pi, we have added x is equal to 0 also. Why? Because when x is equal to 0, 1 plus x sin x is 1 only. When x is equal to pi, 1 plus x sin x is 1 only. Therefore, this is the same one what we are getting. Therefore, we added the endpoints also. Correct. Now, further, 1 plus x sin x is less than 1. Why? For all x belongs to the open interval pi comma 2 pi. Why? Sin x is negative. Sin x is negative for all x belongs to the open interval pi to 2 pi. Look at your sine curve. And x is anyway positive, and the product is negative. So this is negative. So x sin x is negative, and from 1 something is to be subtracted, and that is less than 1. So therefore, f of x is the minimum of 1 comma 1 plus x sin x is, the minimum is 1 plus x sin x, pi, when pi less than x less than or equal to 2 pi. And when you take x is equal to 2 pi, 1 plus x sin x, that will give you that 1 plus sin x value only, and therefore we have added that endpoint also. Thus, f of x is equal to the minimum of the two functions, the first function 1, the second function 1 plus x sin x is equal to, it is 1 when 0 less than or equal to x less than or equal to pi, 1 plus x sin x when pi less than x less than or equal to 2 pi. We continue in the next slide. So that's what we have done so far. And first we talk about the continuity of fx. Now, it is known that first one, every constant function is continuous, and the product of two continuous functions is continuous. The sum of two continuous functions is continuous. So these results are required to talk about the continuity of this function. Now, f of x is equal to 1 is continuous in this interval 0 to pi, open interval 0 to pi, because it is a constant function in 0 to pi. And f of x is equal to 1 plus x sin x is continuous in pi to 2 pi, open interval, using all the three properties of continuous functions. So these three properties you use in this. So what is that we use? Sin x is continuous, x is continuous, the product is continuous, and 1 is continuous because it is constant, and 1 plus x sin x, the sum of two continuous functions, is again continuous. Thus 1 plus x sin x is continuous in the open interval pi to 2 pi using the above three properties. Agreed. Now the continuity, what we said is open interval 0 to pi and open interval pi to 2 pi. So the f of x is continuous everywhere except possibly x is equal to 0, x is equal to 2 pi, the endpoints of the interval, given interval 0 to 2 pi, and x is equal to pi in between, that is the 1. So is there a jump at x is equal to pi? That's the question. Anyway, we discuss in detail this continuity at these 3 points. Now, at x is equal to 0, the value of f of 0 is 1. Agreed. Limit x tends to 0 plus, that is right hand limit at 0 of f of x is 1, and they are equal. Therefore, it's continuous at x is equal to 0. Agreed. At the other endpoint, x is equal to 2 pi. We have the value of f at 2 pi. Substitute here, you will get 1. And the limit x tends to 2 pi minus, the left hand limit, x tending to 2 pi from the left. So it will be limit x tends to 2 pi. For this, the interval, the function is 1 plus x sin x. As limit x tends to 2 pi, 1 plus x sin x is 1. And they are equal. And it is continuous at x is equal to 2 pi. So at endpoints, continuity is achieved. At x is equal to pi, we have f of pi is here 1, and limit x tends to pi minus, that is the left hand limit, is 1 only, and limit x tends to pi plus, the right hand limit, is limit x tends to pi of 1 plus x sin x. As x tends to pi, sin x tends to 0, so this will be 1, and they are equal, and hence continuity is achieved at x is equal to pi. So this given function f of x is continuous everywhere in this given interval, that is the closed and bounded interval 0 to 2 pi. That means there are no points of discontinuity in this interval. So n is equal to the number of points where f is not continuous. There are no points at which this function is not continuous. Therefore, the number of points is 0. Right. We continue in the next slide for the differentiability. Right. So n is 0. Now we talk about differentiability of fx. of f of x. F of x is differentiable everywhere except possibly at x is equal to pi. At x is equal to pi. Why it is differentiable everywhere? Continuous function is differentiable everywhere, and everywhere in this 0 to 2 pi. 1 plus x sin x. Sin x is differentiable, x is differentiable, product is differentiable, the sum is differentiable. So it's differentiable. So the differentiability is in doubt only when this x is equal to pi, at which there is the change is taking place. Agreed? So we take the right hand derivative, that is f prime, first derivative, of pi plus. Right hand derivative means pi plus this side. So this side means limit h tends to 0, f of pi plus h. X is tending to, see, h is tending to 0. It is from right. Pi plus h minus f of pi by h. F of pi plus h is 1 plus, wherever there is x, you substitute pi plus h. So that is equal to limit h tends to 0, 1 plus pi plus h into sine of pi plus h minus f of pi is 1. So 1 cancels, and you will get limit h tends to 0, pi plus h into sine of pi plus h by h. Agreed. And this is the product of two functions we consider. The first function is pi plus h. The second function is sine of pi plus h by h. So the limit of the product is equal to product of their limits. Limit h tends to 0, pi plus h, multiplied by limit h tends to 0, sine of pi plus h by h. Limit h tends to 0, pi plus h is pi. And limit h tends to 0, sine of pi plus h by pi by h is 0 by 0 form. Use L'Hopital's rule. So the derivative of sine is cos by the derivative of which is 1. As limit h tends to 0, cos of pi plus h by 1 is cos pi only. Cos pi is minus 1. And that is pi into minus 1 minus pi, the right hand derivative. We talk about the left hand derivative, f prime of pi minus. Pi minus means from the left. So limit h tends to 0, pi minus h, to the left of pi will be pi minus h. Sine limit h tends to 0, f of pi minus h by minus f of pi by minus h, and that will be equal to limit h tends to 0, f of pi minus h is 1 only, and f of pi is 1 only. 1 minus 1 is 0, limit h tends to 0, 0. So thus the right hand derivative is minus pi, the left hand derivative is 0. They are not equal at x is equal to pi. Therefore, f of x is not differentiable at x is equal to pi. So the differentiability is lost at one point, x is equal to pi. Therefore, m, the number of points where f is not differentiable, is 1. Thus we got m is equal to 1, n is equal to 0. Thus we got the ordered pair m comma n is equal to 1 comma 0. So let's look at our options. Our answer m comma n is equal to 1 comma 0 appears against option B. Therefore the answer to this question is option B. So that is the detailed discussion of the solution of the problem on continuity and differentiability of a given function in a given interval. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.